All right. Okay, so we have a quiz. Maybe we'll start there. Let's begin the process of talking about that. The quiz on Thursday. We'll talk about some more tomorrow, but it looks like everyone is here, so that's good. And so we can kind of get that information out there. So it's over sections 1.4 and through 1.7, which we'll begin to talk about today. 1.7 is really just an extension of 1.6, a lot of the same ideas with a few new ideas, but related ideas thrown in. So I do want to go over the homework in some detail today, because the homework, today's homework that you just got done doing is a really large part of the quiz. All right, so if you felt good about today's homework, that's a good sign. Okay, the things with the chart and those kind of things. All right. So if we talk about 1.4, that was when we got introduced to the F prime notation. Understanding that F prime of 2 means the slope or the instantaneous rate of change of F at x equals 2, right? And we did some things in that section, like here's a graph, and we have to estimate like the slope. So you can expect a scenario where you have to find the slope, maybe by just sketching in a tangent line and being able to draw kind of a rise over run and be able to estimate a slope that way. Okay, be able to do that. Another thing, and looking back at the homework in that section, I can think of a couple of problems specifically. Number 41, 40 we didn't do, but it's a good one. 40 and 41 on section 1.4. I don't remember exactly what page that is. That was the interpret questions, interpret the notation. Remember how many hours of daylight? We said that H is the number of daylight hours. T days after January 1st. What does H prime being negative mean? Well, what does H prime mean? It means the number of hours of daylight per day, the rate that they are changing, that kind of thing. Be able to do those units, be able to take a sentence like that where you're describing a function with the units, those kinds of things. Also along those same lines, we talked about if F is miles and this is hours down here, then F prime is going to be miles per hour. And this will be hours down here. In other words, the x units never change. It's F prime of x, it's F of x, it's F double prime of x. It's the same input, but the outputs are different because the output is rate of change. And if you were going to do F double prime, that would be what in this scenario? Miles per hour per hour. It's always the, which you can do miles per hour squared, but it's also miles per hour. And it's always when you do the derivative, it's the y units divided by the x units. So F double prime means the derivative of F prime, so it'd be that over that kind of thing. But also be able to put into words, not just what the units are, but what does it mean, be able to write that out. So we did a lot of that, just introducing the concept of a derivative, that it means slope, be able to maybe do a slope kind of thing, and so forth. Okay, section 1.5, was about the zooming, if you will. We're not going to do much on the calculator section. The calculator section of this quiz is pretty small, pretty short. The way we will do that is you will do the calculator section first, okay? And so the way that'll work is you get the calculator section, you can have your calculators out, and you will either finish it or put it aside and go on to the no calculator section if you would like to come back to it. So you'll have the option. So if you get done with the calculator section and you feel good about it and you're done, hand it in, put your calculator in your bag or on the floor off of your desk, come get the no calculator section and then finish, okay? But if you get stuck, because you don't want to spend so much time on that calculator section that you don't have time to finish the no calculator. So sometimes people may get stuck or whatever on the calculator section for whatever reason. So if you want to put that under your desk and your calculator under your desk, put that aside, come get the no calculator section. You can do that. Now, the only rule there then is you have to finish the no calculator section and hand it in before you can go back, and then work on the calculator section again, okay, and get your calculator back out and so forth. Okay, so those will be the options. That's how we'll work it. But the calculator section is going to be minimal on this one because if you look at this, there's no calculator necessary really for any of that stuff we just talked about there. Really, it came in this section. In section 1.5 is where we talked about, well, it might have been at the end of section 1.4, but here's where we talked about the H function. Probably have you work with your calculator on that one, unless the function I give you is so simple. And that's where we had this thing with the free fall kind of question, okay, and the velocity equation, I think, was v sub 0 minus 32t, right? So knowing those equations, being able to work with those. And so I think we kind of worked with that in the calculator section because you might have to plug some numbers in and solve whatever. So I would throw it here under this section. So really, this is the only section where a calculator is really going to be necessary, right? So that's why it's going to be a pretty small section. This is also where we did some stuff like if we were going to do f prime of 2, then we could approximate that by doing f of 2.001 minus f of 1.999. Maybe that would be the zooming. That's what I mean by zooming. You're not going to have to do any. I'm not going to do the window. I'm not interested in having you zoom in, make it a straight line, find me a window, that kind of stuff. I mean, we did that more just so you could get this visual representation of the tangent line on a curve. So when we talk about zooming, numerically zooming, this is what we mean, right? Do this slope like so, okay? And then just so be able to work that out on your calculator, type that in kind of thing, and do that calculation. Now, probably would tell you to show your setup. I want to see this, right? If we're doing a slope by zooming, a slope by doing the slope formula on an equation, okay? These are kind of separate problems here, but if we're doing a slope formula kind of thing, I want you to set that up. I want you to see your work, right? Okay, so we have that, and then now we get into section 1.6, and 1.6 is really all of these connections, and so there's just tons of questions. There's not much I could really write down. It's just the chart, right? But it's connections between f and f prime, and it's all this kind of stuff we're talking about here. And probably most of that will be on the no calculator. It'll be a lot like what we're doing here, where they give you the graph and you go with it. Now, some of them they gave you an equation, so you needed the graph. Now, I'm going to talk about how really you should be able to graph those without a calculator, okay? Now, is that going to be a big emphasis on this one? Probably not, okay? So probably not, but I mean, going forward, there's not going to be a time where I'm just going to say, hey, you need to be able to graph these. I mean, really, you need to now, okay? So it's just a matter of whether I want to really emphasize that on the quiz. And I'm telling you, this week it won't be, but does that mean maybe one time you might have to draw a graph? Possibly. Okay, and then we'll add 1.7 in here in a little bit. Okay, so let's go on to this. So 21 through 24. So they give you this. Now, on my picture here, I'm missing a really big piece. I'm missing a really big piece of this problem. Okay, what am I missing? What am I missing here in my picture? What function is this that I'm looking at? That is so critical. Because, and what is it on this one, by the way? F. So the quiz, I said this will be a big part of the quiz. So you can imagine where you've got a quiz question, like here's 4 questions with multiple parts revolving around this question. If you treat this graph as f prime and you answer all those questions that way, you might be right in the way you were thinking. but that wasn't the directions, and so you would miss them all. So I'm not trying to scare you, but I'm emphasizing you've really got to make sure and double check what function are we talking about. It'll be in the directions, okay, just like it was here. So you've got to do that. So I would put a label on that thing and make sure you remember that's what's going on. Okay, so this is the F function. And it's really going to be critical. It's really going to be critical. It's really going to be critical when we get to when we add in F double prime today, right? So you got F, you got F prime, you got F double prime. So you really got to be clear on what's being asked. All right, so 21 through 24. So on what intervals is F prime negative? You know what? Let me bring up something here. Do I have? All right. Okay, yes. Okay, so we had our chart from yesterday, right? And so the first question, 21, where is F prime negative? Well, you're looking for when this graph is, F prime is negative. You see how important the chart becomes. When F prime is negative, F is going down. So we're looking for when this graph is going down, which happens from -5 to where? -2. And from 2 to 5. Now, if you put infinity or negative infinity, that's probably okay, but anytime it's boxed in like this, we usually would just say we're going to stop right there. Yes?
Would it be okay if we put brackets instead of parentheses, like 4, 5?
Let's always put, would it be okay? I probably wouldn't, that would not be counted wrong. But I think in any of the chart stuff, the intervals we do, let's do open parentheses. And that's typically what the AP test is interested in. Okay? If you put brackets, some of the chart stuff, it's probably wrong to put brackets. Some of it's okay. It's never wrong to put parentheses. So that's why I would say do that. Okay? B says, where is F prime decreasing? Now, it'd be nice if eventually we can get to the point we don't have to look at the chart every time when we do these. You can just think it through. Okay? But in the beginning, maybe not. Okay? F prime, you do enough of it, you kind of get it. F prime decreasing is when F is concave down. And so F is concave down from 0 to 5, it looks like. Now, we don't know for sure where that inflection point is, but it looks pretty reasonable. Now, you may get some problems where in the directions they will tell you. They'll say, this is the graph of F. F has an inflection point at 0. It has a local minimum at -2. It has a local max at 2. But I think for the most part, we can assume it's going to be at nice points if it doesn't tell you otherwise, okay? So we're not interested in tricking you and making you estimate those points necessarily like so. Okay? Where is F prime positive? Well, that's just kind of the reverse of those, right? So 22 is just kind of the reverse of those. So now we're looking when this graph is increasing, and we're talking about where it's concave up. Okay, so let's move on. So 23, where does F prime have its max value? Where does F prime have its max? When F prime, okay, so let's think about that. So that means when the slope is at its max, right? So, and slope is a number. So when is a number its biggest? Well, if it's positive, it's when it's its biggest positive, right? If they're all negative, it'd be where it's the least negative or closest to 0, right? But in this case, we have slopes that are both positive and negative. So it'd be wherever it's the most positive, and so where it's going up the steepest, which would be at the inflection point. So at x equals 0, and I would want you to put at x equals 0. And then it says estimate this value of F prime. So now they're asking for F prime of 0, and they're asking for an estimate of that. So what do we need to do to get that? sketch. Okay, so remember I said on the quiz, might be expected to do something like that. That's exactly what you need to do here. So they want to know the slope of the F graph at 0. So I would want to see, if this is a quiz question, I would want to see this on your paper, and I would say you'd want to go over 1 to make it easier, and it looks to me like I would go up, I don't know, somewhere in there. So over 1, it looks like it goes up about 1. So did you say 1 on that one? Now I would give you a little leeway, probably anywhere from about 0.8 to 1.2 or something like that, I think, is reasonable. Whenever you do that, make sure you look at the scale and make sure you've got the right scale on your numbers. Yeah.
So you want us to do like the F at negative 0.001. You wouldn't want to see it there at the actual numerical.
Why would I not want you to do that one numerical?
Because we don't have the function.
We have nothing to plug the 0.001 into. Make sense? Yeah. Yes, I would love you to do that. I would say get the best estimate you can. So if they'd have told me an equation for this, then definitely I would have wanted to do that, right? But since all I have is a graph and no other information, I think this is the only way to do it. Okay? Yeah, because otherwise you'd be saying, well, 0.001, you'd just be guessing at those values too. You know what I mean? You'd just be guessing at what those were. So I think this is probably even more accurate than that, to be honest. Okay? All right. So 24 then says sketch F prime. Okay, so yesterday we did some F graphs from F prime. Here we want to graph F prime from F. So yesterday when we had an F prime graph, had to graph F, we said we didn't know where to start it because all we knew was what the slope was, but we didn't know where it was. Well, this is different, right? I mean, we know, so what we're looking at is what's the slope right up here? See how it's opposite of what we were doing yesterday? Yesterday we were looking at the Y value. Here we're looking at the slope. It's negative and really pretty steep negative. So that means I'm going to plot a point probably down here somewhere, right? So let's just go down here as far down as I can. And then, but what's happening? They're negative and getting all the way to 0. So isn't my graph going to have to hit right there?
Yep.
Very good. Then they're positive slopes and getting more positive till there. And we said what was happening there? No, well, yeah, it's an inflection point on F, but what is it on F prime? It was a max, right? On 23, they said, where's F prime have a max? We said it was right there. So our F prime graph better have a max right there. So so this graph's coming up like so, and then it's going to have a max right about there. I mean, I don't know where it is for sure. I didn't want to go right to that point because we don't know that it would go right to that point. I just want, but on the y-axis somewhere, there's going to be a max. And then the slopes are still positive, but getting less positive until they're going to get back to 0 right there, right? Because there's a 0 slope right there, so it's going to come back down. And then they're negative and get more negative. So parabola-ish. Okay. Turns out I think it would be a parabola. Yeah. Well, assuming. But it would look like that. Okay. So there's the F prime graph in red. All right. Let's go on to this section. Again, I apologize if these are too easy, but I don't think it's a waste of time to really talk about these things. It's very critical ideas. All right, so what do they tell you? Here's a function g. So again, what am I missing here? This it's not f though. It's g prime. Is that right?
Yeah.
These exercises concern a function g whose derivative is shown below. Okay, so this is g prime. So you really got to read the directions carefully. So this is g prime. All right, so 25 says, where is g increasing? Well, g is increasing when g prime positive. So we're looking for where this graph is above the x-axis. Now, this gets a little bit towards what Lauren was saying. So where is g increasing? We would say, well, when g prime is positive, right? Well, that would be from
0 and 5.5.
You're calling this 5.5. I think that's reasonable. And 9 to 10. Anybody have an issue with that? Heck no, that's what the back said. I don't know. Is that what the back said?
Yeah.
I'm curious. That is what the back said. Does anybody have an issue with what happens right there? It's not negative, right? But is it positive? So we were saying we were looking for when G prime is positive. It's flat there, right? So the graph's going to be, the G graph's going to be going up. It's going to flatten there at 1 and then keep going up. So do we consider that to be increasing the whole time? Yes. Yes. I was trying to lead you to that. I got you. It actually, but it's only flat for an instant. So let me give you, here's why it's increasing. So this gets into a little bit of a technicality, but I think it's important. What does it mean for a graph to be increasing? What it means for a graph to be increasing is as you go from left to right, every time you move to a new x value, no matter how small of a move you make, that the next y value is a little bigger than the one before. That's what it means to be increasing. So even at the spot where it flattens, that y value is a little bigger than the y value before it, and the next y value after it's a little bigger than that one. Even though it's flat, it seems weird. You would think for it's flat, it has to be flat for a while. No, it's what it means to be flat at that point is the tangent line would be flat. So think of x cubed. X cubed comes up, has a flat spot at the origin, and then goes up again. Every time you cube a number, doesn't it get a little bit bigger than the one before? It does. So as you take a negative and you cube it, you get a negative, it's a little bit bigger, and then you get to 0. So right before 0, you have a negative number cubed, so that's negative. Then you get 0 cubed to 0, and then you have a little bit of a positive right after it. You cube that's a little positive, right? So every number, every y value is a little bigger than the one before it. So that graph's increasing. So even though it flattens just at that one instant, we do say it's increasing all the time. So again, a little bit of a technicality. When we say G is increasing, what that means is G prime is actually greater than or equal to 0. Now all right? So our chart's a little bit of a cheating here. It's not real technical, but this is just to help us. F increasing means F prime's greater than or equal to 0. So it can be 0. So the fact it didn't bother you, that's okay. As long as it doesn't go negative, G prime doesn't go negative, then G is still increasing, even though it's flat, just for that one instant. Okay? All right. So this is a fine answer. Now, if you said 0 to 1, 1 to 5.5, 5.5, or then 9 to 10, technically that's probably wrong if you leave out the 1. Okay? So, again, I'm glad it didn't throw you off, because if you look at the chart, we're saying, hey, G prime is going to be positive. It's not positive there. As long as it stays positive, the answer to the question was, or the question was, is G increasing? So now, let me ask you this. What if the question was, where is G prime positive? Would we leave out the 1? Then we would leave out the 1. See what I mean? So again, it's a little bit of a technicality. So we got in our head, G is increasing when G's prime is positive. So you just say, well, where's G prime positive? Oh, we got to include the 1. But if the question was, where's G prime positive? You can't include the 1, right? Because it's not positive there. So a little bit of a technicality. I don't see that being an issue. So I don't think it's something you really got to worry about. But I think you just got to answer the question. Okay? All right. So moving on. 26. Where's G decreasing? So that would just be at the other spots, right? Wherever this is negative. So from 5.5 to 9. Where does G have stationary points? So I want you to write x equals 1, 5.5, 9, right? It's where G prime is 0. So I want it to look like that. Okay? You don't need to use set notation or anything like that, but x equals is important. Because it says where. Where does G have a local max? What's first derivative test say? It says G has a local max when G prime switches from positive to negative. When G prime switches from positive to negative, that happens right there. So x equals 5.5 is what we would say. Local max of 5.5. Where does it have a local min? X equals 9. When this goes from negative to positive. Okay? Is G concave up at 3? G is concave up when G prime is increasing. So, is G prime increasing at 3? Yes. So is G concave up? Yes. Justify your answer is, since G prime is increasing, G is concave up at 3. That's the justify your answer. Okay? Is G concave up at 6? No, because G prime is decreasing. So therefore, G would be concave down. The graph of G has a local max at 3.8 and a local min at 7.4. That is right here and here. What do these facts say about G? What's going on at G? Inflection points. Local max and mins on the derivative mean that the derivative is switching up to down. If the derivative, the bottom row here, switches from up to down, then the G graph switches concavity, so you have an inflection point. Okay? Suppose that G of 0 is 0. Sketch a graph of G. Okay, so let's do G in red here. So the G graph's going to be in red, and they told us a starting point, right? Yesterday we were saying, hey, we don't know where to put this, but they told us G of 0 is 0, so we know the G graph's got to start there. Okay? And so now what? It's got to go up, because now we're looking at the y values of the blue graph, right? G prime is the slope, so it's got to go up and keep going up until here. And what do we say is happening here? Flat spot. So it's got to go up and flat. Positive y values, but getting less positive means slopes getting less positive. Then keeps going up until inflection point. So it's gonna turn and kind of go up like so. I'm gonna run a room here, so I'm gonna keep it pretty flat. So it's gonna go up, up, up until there. That was an inflection point we said, right? Positive getting more positive. Then it's positive getting less positive until what we have here. We said that was going to be a local max. Okay? So, and it makes sense. Look at our graphs going up all the way to 5.5. Didn't we say that in our first answer? Increasing from 0 to 5.5 was G. So this graph's increasing all the way to 5.5. Now we got local max. Now we got negative slopes getting more negative until about 7.4, which is we said was an inflection point. And then negative and getting back to 0, so it's coming down like so, which we said was a local min. Positive and getting more positive means it's going back up. So something that looks like that. Something that looks like that. So we got a flat spot there. That's an important point. We got an inflection point right there, which corresponds to that. We got a max, which corresponds to that. Inflection point corresponds to that. Minimum corresponds to that. Okay? All right. Suppose G of 3 is 4. Find the equation of the tangent line at 3. Okay, right away, you better be thinking this, right? X minus A plus B. We need a point and a slope. Well, they gave us the point, 3, 4. That's easy. All I need is a slope of G at 3. G prime of 3. Isn't that y value right there? We just look at that y value. The slope of the G graph at 3 is 2. Boom. We're done. That's it. Okay? Distribute it, simplify it if you want to, but you don't have to. Suppose that G of 9 is negative 1. So, same thing, except we got x minus 9 minus 1. Find the equation of the tangent line. So now we need the slope at 9. What's that? 0. Oh. Leave it, but it would be y equals negative 1. Be a horizontal line. Oh, yeah. Right. It'd be this line right here. Be this line right here. Right? This is the G graph in red. Tangent line would be right there. So is my picture any good for that one? But then it shouldn't be, because they told me G of 9 was negative 1. Here we based our red graph on G of 0 is 0. It's a different G graph, right? The one they're talking about would have been shifted down a little bit, right? So this tangent line, the way I drew it's actually about y equals 1, right? But that's because I started in place. Plus, this was pretty rough. I'm just kind of guessing where to go here. So they gave me different G values. Remember, that red graph could be shifted up and down if you had different starting points. Okay? All right. 36. Could the G function be x times sine x? Here you would use a calculator. I would graph that thing and say, okay, is that it? Does that look like x times sine x? And see if that just looked like my red graph. Do you, Matthew, is that what you did or what?
Yeah, that's what I
You did, okay. So if you just graph it and say, could that, and I don't think it looks anything like it. So.
Did you argue that like it's not a sine graph because there's no periods or anything?
Yeah, but when you put an x in front of it, when you do x times sine x, and that changes things. That changes the fact that it's periodic and stuff like that. So you pretty much have to look at it. Okay? And I think that's what they were wanting you to do. Okay, so a lot of stuff in there, asking questions about the chart, very common type of problem that I'm going to be giving you on the quiz. Quite a few of those. Here's an F graph, answer these questions. Here's an F prime graph, answer these questions. Okay? So we did one of each. We just did one where you started with the F graph, and we started one where you start with the derivative graph. Okay? All right, 46. Now they gave you this picture here. Now, I want to talk just quickly about how you should know how to graph some of these very basic curves. I mean, this is a negative parabola, so it's going down. It's shifted up 3 because you could rearrange this as negative x squared plus 3. Another thing I'd like you to know about a normal parabola, as long as it hasn't been stretched or compressed, which this one hasn't, a normal parabola goes over 1 and up 1, or now down 1, right? Because 1 squared is 1. What's 2 squared? 4. What's 3 squared? 9. So a normal parabola from its vertex should go over 1 and down 1, in this case down, over 2 and down 4, over 3 and down 9. It's a real quick, easy way to do a parabola. Now, once it's been stretched and stretched anyway, or compressed, then it gets a little trickier. But as long as that hasn't happened, it's a quick way to draw a nice parabola. So on the no calculator, like on the AP test, they sometimes will give you questions like this, and you can't use your calculator. You got to be able to draw a decent graph of it. Okay? So I think that's the secret here, is graph. Now that's F. So 46, we'll get through this quickly. How many roots does F prime have? Where is F prime 0? Which is right there at x. So how many does it have? It has 1. Where is it? X equals 0. That's the only time the slope of F is 0. Okay? Where is F prime positive? Negative infinity to 0. It's when this graph is increasing. This graph is increasing until there. Is F prime increasing at 2? F prime's increasing when F is concave up. Is this graph ever concave up? No. So the answer to that is no. And then sketch a graph of F prime. So here's F. So we want F prime. So the slopes, so we're looking at the slopes of this, right? So the slopes are positive and really big. So out here, we'd be up here somewhere. And then their slopes are what? Getting less, heading down towards 0. Right there, we know we have a slope of 0. And then they're negative and getting... Now, does it have to be a line? Turns out it actually is a line. But if you kind of curved it in there a little bit and made it kind of curve and zigzag a little bit, you could. But it's basically going down the whole time, something like that. Okay? All right, so that's 46. 51. Now, again, you should be able to look at this and say that is a parabola, because if I FOIL that out, I got an x squared. It's going to be facing up. It's not stretched or compressed or anything. It's just one of these things. So if I plug in so that means I go over 1, up 1, I go over 2, up 4, I go over here, up 9. You can check it. Like if I put a 2 into here, I get 0. If I put a 4 into here, negative 4, I get 0, right? So we know those are the roots, 2 and negative 4, so at least we know that. But again, I can get a decent looking graph of this without going to my calculator, okay? Because the roots are easy to find when it's in that factored form. So I got 2 and I got negative 4. But this time it's F prime, not F. All right, so Where is F increasing? F's increasing when F prime is positive. So we're talking about positive would be negative infinity to negative 4 and 2 to infinity. When this graph is above the x-axis is when it's positive. Okay? And we would not want to include the endpoints. That's what we were talking about before. We would not want to include those endpoints there because where it's positive, but is it increasing? So it doesn't really matter. At which values of x, again, if you did, could be okay, but at which values of x does F have stationary points? Negative 4, and I want you to write x equals negative 4 and 2. Now, never fails where I get somebody, they say, where do we have stationary points? And they see these points here, and they'll write this. They'll write negative 4, 0, and 2, 0. Now, why is that wrong?
Because that's an interval.
Well, you're right, but I would, yes, we usually use that as an interval. But in the context of this problem, since it asked where, now it did say values of x, okay, but even that, where does it have stationary points? To me, it's a point. So I would read that as an ordered pair. So I would give you that. But again, why is it wrong? Say that again. Yeah, this is a point on the F prime graph. They're asking for where does F have stationary points? I don't know what the Y value is on the F graph, right? So that's actually wrong to put negative 4, 0 and 2, 0. Okay, and that's why the question is very specific. What X values are their station points? So you've got to put X equals negative 4 and X equals 2. Do not write it like that. Okay? At what value of X do we have local minimum? That one? Local minimum is when the F graph goes down and then up. Down and then up. Means F prime has to be negative, then positive. Okay? And that happens right there. Negative, then positive. First derivative test. Local minimum. Okay? Which interval is F concave down? F is concave down when F prime is going down. That's from here to negative 1. Negative infinity to negative 1. Right? Sketch the graph of F. Okay. So, in blue here, the graph of F. What are we looking at on this graph? This is the F prime graph. So we're looking at the Y values. And then we're going to plot F. Now we don't know where to start F, right? We don't know where to start it, but we know that these Y values here in the beginning are positive, and over here they're really positive, so my graph's got to be going where? Up. My graph's got to start out here by going up, right? And what's happening right there? F will have a local max. So I got positive and getting less positive, so my graph's going up, 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 until there I got a local max. And then negative, 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 getting more negative till there. What do I got going on right there? Inflection point. So at negative 1, so this is coming down until there, I got an inflection point. Then they're negative and getting less negative. So that means it's leveling off until there. Local minimum. What we just said was a local minimum. And then positive and getting more positive, like so. Okay? So F, if I look at the F prime graph, look at its Y values, they're positive, then negative, then positive. So that means this graph's got to be going up, then down, then up. Okay, another way to look at it. Okay, inflection point is a local max or min of F prime. That's what we got right there. All that information's in the chart. Just go slow, take your time through it, okay, and we can do this. All right, let's talk about, next thing I want to do is get your chart back out in your notes, okay? So, again, if that all felt really good to you and comfortable and you kind of knew what you're doing, and hopefully maybe this just ingrained it a little better, because I think that is important. I don't think you can know this stuff too well. All right, so what we're going to do is add a row to our chart for F double prime. Now, if you want to start over and redraw a new one, it's probably not a bad idea. Helping you to be able to draw this is probably not all bad. Okay? So we're going to have an F, we're going to have an F prime, we're going to have a double prime. We're not going to add any more to it because, as you'll see, they just start to become copies of each other. All right, so let's just redo the parts of it that we had yesterday. So we started where F prime was 0 right here. And what did we say about F? Stationary point, which could be local max, min, flat spot. Right? If F prime is 0, we got local min, local max, flat spot. Okay, what came next? I'm doing the F prime, bro. F prime could be positive. So F is going up. And then F prime negative means F's going down. Right? And if we switch these columns back and forth, that was our first derivative test. Right? That was our first derivative test for a max or min. So if we switch from up to down, that means F prime had to switch positive to negative, and vice versa. Okay? And then we had what? F prime could be increasing. That meant F was concave. Oh. Concave up. Or F prime can be decreasing, and that could be concave down. And then we could have a switch of columns, which would make an inflection point. Correct? All right, now, we're going to add in F double prime. Now, first of all, let's start with the easy one here. F double prime is simply what? The slope of F prime. So all of these connections we've talked about F and F prime, aren't they exactly the same for F prime and F double prime?
Yes.
Exactly the same. So take the problem we just got done doing here. If they would have told me that this was F double prime, and they would have asked all these questions about F prime, been the same problem, right? So one of the reasons I said 1.7 is kind of easy after doing 1.6 is a lot of the stuff in 1.7 when we go to the second derivative is the same as what we did before. So if I gave you an F prime graph and asked you about F double prime, that'd be the same as an F graph and asking you about F prime, right? So anytime you get that connection, that F prime, F double prime kind of connection, it's the same as F prime. Because F double prime is simply the slopes of F prime. F double prime is the slopes of F prime. Okay? So, let's fill that in. So, what could we do down here? Let's see. Well, right here, when F is increasing, we knew F prime was positive, right? So right here, when F prime is increasing, we know that that's got to be positive, right? And when F prime is decreasing, we know F double prime is negative, right? Now, so the question is, what about these over here? Well, let's think about this a minute. What if the F prime graph is 0? That means it crosses the x-axis, right? So if the F prime graph crosses the x-axis, does that tell you anything about its slope? It could cross in all sorts of ways. Notice we never had a 0 up here and then something below it, right? So we're not going to have anything there. What if we know F prime is positive? That means the F prime graph is above the x-axis. Does that tell you anything about its slope? No. And same thing here. If F prime is negative below the x-axis, does that tell you anything about slope? No. So these will not have anything in it. There's just no connections there, just like there's no connections from F to F prime if these are 0 positive. Nothing there. Okay. Now, so what are we missing in the F double prime row? Well, we got the positive, we got the negative that we have here. We're missing the 0, so that probably should come next. So what happens if F double prime is 0? Now remember, this is the slope of the one above it.
There's a local max flat spot.
That means we got a stationary point of f prime. Now you see how it really becomes important what function you're talking about. You're talking about f, you're talking about f prime, you're talking about f double prime. So if we have 0 on f double prime, it tells me we have a stationary point, which would be a local max, local min, or flat spot of f prime. Right? Now let's jump up to f. Well, no, let's don't just yet. Let's don't just yet. Let's keep going. So I got plus minus 0 in my f prime row. I got plus minus 0 in my f double prime row. So now what about this? What about increasing, decreasing? Should throw those in there. So what happens if f double prime is increasing?
That's positive.
No.
F prime's
Concave up, right?
Oh,
So right above concave up, right, or right below concave up is increasing. So we should have that same connection. So if f double prime is increasing, f prime is concave up. Now, does that tell us anything about f? No. If it did, we would have had that in there already, right? F prime being concave up doesn't tell you anything about f, right? F prime concave up, those would be the slopes. Well, that doesn't tell you anything about f. So there'll be nothing up there. Okay, and then same thing over here, the decreasing piece of this would be concave down, right? So now let's just look at the f prime, f double prime rows. So just look at the bottom two rows. So we got 1, 2, 3, 4, 5 things, and then there are 5 connections here. Now, isn't this bottom section of the chart right here, isn't that the same as the chart we had already today? Right? We had 1, 2, 3, 4, 5. We had these 5 things here, right? That was our chart. And now we got those same 5 things here. So that's what we said. F prime, F double prime have the same connection as F and F prime, right? What's the new part of today then is what new things have we gained? That is, what can F double prime tell us about F? So let me write that down. Okay, so yesterday we had the F prime connection, right? And we've now stated, and I think we're convinced, that F prime to F double prime, those are exactly the same, right? So all of those connections are exactly the same, right? The new thing is, what is the F to F double prime connection? What does that tell us? So that would be the things in the bottom row. What do they tell us about the top row? Well, the first, so that would be this section here in red. That would be this section right in here. Okay? So F double prime positive tells us F is concave up. Interesting. F double prime positive tells us F is concave up. It's kind of like going, you got a middleman in there. F prime's like the middleman, right? It's like the old transitive property geometry. If F double prime is positive, that means F prime is increasing. But if F prime is increasing, that means F is concave up. So therefore, if F double prime is positive, it means F is concave up. So we gained a new connection there, right? And if likewise, if F double prime is negative, it means F is concave down. And then, what about the 0? Almost. When did we have an inflection point? When F changes concavity. That happens when F prime goes from up to down or down to up, right? Which are what? Local maxes and local mins. What about that one, though? Would you have a change in concavity? If F prime was going up, F prime now is going up and then keeps going up. If F prime's going up and keeps going up, F is concave up and stays concave up. Do you have a change in concavity? No. So it's only these two scenarios. So again, let's say this. If F double prime is 0, does not tell you for sure you have an inflection point. It tells you that F prime might be a local max, local min, or flat spot. It's going to be one of those. If it's a local max or min, then we have an inflection point. If it's a flat spot, we don't. So what I usually put in here is pip. Why do I put pip? Possible inflection point. possible inflection point. What you have to have, though, is a change of concavity. That hasn't changed. Our definition of inflection point is there has to be a change of concavity. All right, so now, let's investigate that just a little bit more. So let's talk about F double prime now. So let me put a little graph of F double prime down here. So F double prime positive. So what would give us a switch of concavity if we change columns, right? That means we have to change these two columns, correct? So F double prime's got to go positive to negative or negative to positive. So F double prime's got to go down through like that, or it's got to go down through like that. But what if it bounces?
It's a flat spot.
It's a flat spot of F prime, and is it an inflection point of F? No. So here's how you would look at this. You'd say, okay, F double prime is going positive to negative. If F double prime goes positive to negative, F goes concave up, concave down, we got an inflection point. If F prime goes negative to positive, then this goes concave down to concave up. Got an inflection point. Now, don't forget F prime in the middle, right? If this goes negative to positive, remember we've been called that a local min because we were going from F prime to F. So what we got is if F double prime goes negative to positive, F prime goes down to up, which is local min, which means we got an inflection point, right? We're changing columns. Okay. But F double prime, and it's 0 in both of those cases, right? F double prime is 0 in both those cases. But here F double prime is 0, but we don't get an inflection point because F double prime is positive and then stays positive. So therefore you stay in this column. F double prime is positive, stays positive. No change of concavity, no inflection point. All right. Now, this red box I have here, here's one takeaway that I would like you to have out of all this stuff we've talked about. When you hear F double prime, and you're talking about F, think concavity. Think concavity. That's really the only connection. If we talk about the F to F double prime connection, it's really all about concavity. That's all it is. We only have these three things, right? When we go F double prime to F, that's the only three things we have here in our chart. If F double prime is positive, tells you concave up on F. F double prime is negative, tells you concave down on F. And if we switch those, if F double prime is 0, if F double prime is 0, it means we might have switched concavity. But we had to have switched from positive to negative, so it had to go through. It couldn't have bounced off. All right, so a lot there to still make sense of, so we're going to do some more homework questions, and we're going to review and talk about it again tomorrow. Okay, but that's it. That's the whole chart now. That's the whole chart. Okay? All right, so let's take a look at, in your book here, if you turn to page 65 real quick. Down at the bottom of page 65, we get a little more of a definition of concavity. Concave up means that the tangent line, another way to think of concave up and concave down rather than curving is concave up, the tangent lines are below the curve, and concave down, the tangent lines are above the curve. Okay? So that's a fact that we're going to make use of as we go through. So that is something kind of important. When you go to page 66, please, page 66, they have something called the second derivative test. The second derivative test. Now, we're going to talk about that here in a minute. We're going to go through some of the kind of the homework problems together as part of what we do here. So we're going to talk about the second derivative test. Again, it's about local max and min, just like the first derivative test. First derivative test says you got to switch columns, right? F prime has to change from positive to negative to be a local max. Okay, we're going to talk about how the second derivative could be used to find the local max and min as well. All right, and then look at the bottom of page 67, okay? They give you an F prime graph there. Let me pull up that chart one more time. Oops. Okay. Okay, they give you an F prime graph and they ask you some different questions real quickly at the bottom of page 67. Estimate F double prime of -3. That's the slope of that graph. How would you do it? Sketch in a little tangent line. That's all you can do, right? You don't know the equation or anything. So they give you the F prime graph. They ask you F double prime of -3. That's the slope of F prime. You sketch in a little tangent line there. Do a rise over run. Right? Do a rise over run, just like we talked about before. Where is F concave up? F is concave up. Well, there's nothing new in this question, right? Because that's an F prime graph. So F is concave up when F prime is increasing. So when that graph is increasing is when F would be concave up. So that's just FF prime stuff. I thought we'd have something a little new there. I guess the first part was the only thing that was really new. Where does F have inflection points? An inflection point is when F changes concavity. Well, that's when F prime switches up to down, down to up, right? So that would be where? -1 and 3. -1 and 3, right? Okay, so I wanted to touch on that. Okay, here's part of your homework, number 4 through 8. So we're going to do this together on page 68. Page 68, so I want you to write this down. So go ahead and get your, go to wherever you're going to do your homework on this page, and we're going to start with 4 through 8. And we're going to talk through this together. So, page 68. So read number 4 and see, go ahead and jot something down real quick if you think you got it. You can go on to 5. You already got 4. Well, are we just doing 4 through 8 for the homework? No, but right now. I mean, that's yeah, just 4, 8. Okay. I want to give you enough time. If you're on to 5, that's fine. But it says J prime has a local max at 2. What's that tell you about J double prime? J prime has a local max at 2. So if it were me, I would probably have sketched a little something maybe and done something like this. Yeah. That could have been there, but it also could have been down here, right? And that's J prime, right? What's that tell me about J double prime?
It equals J double prime 2.
J double prime would equal 0 at that point because that's the slope of that, right? Now, what I left out is there's another type of local max we haven't done a lot with, but that's a sharp point. What would J double prime be in that case? Undefined. Now, I think for this quiz, we'll go ahead and assume everything's nice and smooth. Matter of fact, I think in some of the directions on your homework, and there could be some in the quiz too, where it'll say, assume the function is differentiable. Differentiable means the derivative exists everywhere. It's continuous. It's nice and smooth. It just means it's really one like we would think it was nice, smooth kind of graph. So there are some problems where we can just assume that's the case. So I think on this one, you'd be fine to say it means J double prime is 0. J double prime is 0, okay? Because it'd be the slope at that point. What's it tell you about J? There's an inflection point there because that's what we were just talking about. J prime goes from up to down. If J prime goes from up to down, that means J went from concave up to concave down. So you had an inflection point there. Okay? All right, number 5. They give you this information and they ask if you have a local minimum. Do you have a local minimum with just this information? It's one of the reasons I like this book because you really ask these questions in different ways to really make you, do you really understand what's going on? So what do you think the correct answer is?
Yes.
Why?
Because
Because
F prime equals 0, which makes it a stationary point, and then but the F double prime gives it a slope, and so it's going from the negative to positive for the y values.
expand on that. I think I hear what you're saying, and I want to.
the F prime graph at -3, y is 0,
Makes it
but
stationary.
F double prime gives us the slope of that line.
We don't know if it's
which
going up
means
or
it's
down,
going
or
from
the
decreasing
slope's
to
going
increasing,
down or left.
meaning it's concave up.
And actually, I heard you say something. I think. Did you say something about concavity? Who said that? Somebody. I thought somebody said concave up. Oh, that was you.
I heard Akshay say it.
I thought you could.
Actually, you definitely said it.
Yeah.
Right. Okay. Maybe that's what I heard. Okay. I want to get back to that, but no. I think you're agreeing with Andy then, right?
Yeah.
You're kind of saying same thing. You're saying if we had an F double prime. No, excuse me. If we had an F prime graph here, the fact that it's 0 at that point means it's crossing.
Yeah.
And since the slope's positive at that point, it means it's got to be going through like that.
Yeah.
Which means negative to positive. It's not bouncing off, right?
Yeah.
If it was bouncing off, we'd have a slope of 0. Since it's got a positive slope on the F prime graph, it means F prime is going from negative to positive. And so if we look at the chart, if F prime is going from negative to positive, what's F? Down to up. That's a local minimum. Now, what Akshay said is actually more along the lines of the second derivative test. Andy said the first part exactly right. Do we even care about this? Nobody said anything about that, and I agree. That just tells us where the point is. But it doesn't tell us what the point is. It just tells us where it is. This is telling me right here. So he really zeroed in on the key thing there was when he said when F prime was 0, it's a local max, a local min, or a flat spot. We know it's one of those 3. And then what Akshay said, and its slope is a positive. The second derivative positive tells us what about F? Concave up. Well, now think about a local max, a local min, or a flat spot. Which one of those is concave up at that point? The local min. What's this one? Concave down. Local max. What's the concavity on this one? Neither. It's changing, right? On a flat spot, it's not concave up or concave down. The second derivative test says if you know you have a stationary point, which we did here because we knew F prime was 0, since we had a stationary point, to tell if it's a local max or min, you can look at the second derivative. Instead of seeing if it's changing at F prime, the first derivative test, just plug into the second derivative if you know it. If you get a positive, it's concave up. That's got to be a minimum. If it's negative, it's concave down. Got to be a maximum. If it's 0, you know it's a flat spot. and it's not either one, right? So there, but I like what you guys said, where you said, you know, that's a positive slope, so you know it's crossing through. I like that too. That's the same rationale. Okay, good problem. So number 6 is the very same thing, but I'll quickly go through that one. It's not a local max. Why do we know right away it's not a local max?
G prime doesn't equal.
G prime, yeah, G prime doesn't equal 0. They say G prime is 2. So of all that stuff they tell you on 6, they tell you G prime is 2. That means the slope of G is 2. So it means it's going up like this at 2. It can't be a local max or local min. G prime's got to be 0. So right away you would know it's not. All right, very quickly on 7 and 8, I'll just tell you this. They give you F prime, and it's a parabola. And I'm not going to make you go to your calculator and graph it, but when you did, it would look like this. So why are there 2 stationary points? Because it crosses the x-axis twice. It's very simple. But, okay, so there's that connection. So we probably wouldn't do one like that on the quiz just because I'm not going to have you the calculators. And then they tell you F double prime, next question, is 6x minus 2. Now this we certainly should be able to graph. Oops, oh, that was bad. Missed it. Goes through -2, and it's got a slope of 6, so it's pretty steep. This is F double prime. Explain why F has only one inflection point. One time. Remember, for F to have an inflection point, you've got to switch concavity here. For F to switch concavity, F double prime's got to switch from positive to negative, or vice versa. Well, that only happens one time. F double prime switches from negative to positive. F double prime switches from negative to positive one time. So therefore, according to the chart, F switches concavity one time. So we know we have one inflection point. Okay? All right, last thing we're going to do, and this is what I need you to be locked into your calculators for. This is number 26 on page 70. And I'm going to send this to your calculators. So you have to turn your calculators back on. You may have to log back in. I don't know. It looks like 24 people are logged in. Gabe, Brianna, Casey, Andy, for some reason, aren't logged in. Aren't, according to this, but you might have to.
Oh.
Might have, maybe if it went to sleep for a while, I don't know. There you go, Casey. Okay, so you should get this little poll here. You getting that? Identify F, F prime, and F double prime respectively. Okay? And then so I said examples, so when you type your answers in, so everybody's the same, just use lowercase, like BCA. So in other words, if I go back to this, okay, so here's graph A, graph B, graph C, we can just use lowercase. So I want you to do them in the order F, F prime, F double prime. So if you think B is F and C is F prime and A is F double prime, then type in BCA for your answer. Okay, that's what we're getting at there. Okay? And you can talk about it with each other if you want to, or you can just try to get it on your own. So one of those is F, one of those is F prime, and one of those is F double prime. Okay, go.
Shift. I think someone wrote the answer.
Oh, yeah, somebody wrote it in and erased it. Don't look at it.
Too late.
Too late. Yeah, I know.
They take out the shift on my average caps on.
Oh, I don't know.
Not sure that helpful though. That's fun.
No, there.
Or control shift, maybe control shift.
I got it.
Caps on. No. Well, even if it's written in there, try to reason your way through it. Give you a hint, I would start at the x-axis. I would start along the x-axis is where I would be looking. And if you get it, go on. I mean, if you think you got it, go on and look at 27 also. But don't type that in your calculator. Just type 26 in your calculator and submit it. But if you think you got it, go on and try 27.
Why is
Maybe it's gonna be,
half big eggs?
there's eggs or something.
No, maybe that means it wrong.
I can make it.
Or it might be.
Yeah.
Oh. It's level off. That's what I have.
You don't have to submit. Up under the poll, I think you submit. I think I can see when you type it in. Submit would just mean you finalized it. But
I kinda cheated.
I'm still gonna find that work.
How?
But
it's not letting you on.
Like some days I can find a network, and other days
Oh, yeah.
it's erased. It makes sense.
Yeah.
Sort of.
All right. So I think we've got answers here for the most part. And I see some people still changing. It's all right. I'm going to stop it. But all right. The most common answer was BAC. And the next most common was CBA.
Yay.
Okay? Oops.
Oh.
All right. So now here I think would have been my thought process on this. So I might have came in and I'd have looked right there, thinking of the F prime middle row of the chart. And I'd be thinking, okay, if this is F prime, it's going from positive to negative, make F a local max. So one possibility for sure is that this is F prime and that this is F. But that also could be what?
It could be F double prime.
This could be F double prime and this
F prime.
F prime. Remember, F and F prime have the same connections as F prime and F double prime. Okay? So, but let's go with that first one that I said. All right, let's go with the black. So that would make this one F double prime. So then what I would do is if I think I found that F prime relationship, then I would make sure it continues that way. So, positive, concave, this is increasing. Then it's negative and it keeps decreasing. Seems to work. Okay? Now let's bring in F double prime. What did I learn on F double prime? I learned on F double prime that if it's negative, which this is the whole time, right? F double prime is negative this whole time. Then what's that tell you about F? Concave down the whole time. Right? Think back to the chart. If F double prime is negative, F's got to be concave down the whole time. So if I look here, since F double prime is down here, negative the whole time, that means what I call this, the F graph? Yeah. It's got to stay concave down the whole time, is it? I'm not too sure over there. That looks to me like that's switching to concave up. So now all of a sudden I don't feel very good about that one. So that would have been the BAC one, which was our most popular answer. Now, what about the one in the red? If this is F prime and F double prime, that would make this one F. So let's look at that connection. So let's do the first one we learned, which is the FF prime connection. So if F prime is positive, which it is all the way to there, what's that tell you about F? F prime positive means F's increasing, which it looks like it is all the way to there. So here's this looks like a local max. It looks to me like I do have a local max there. Positive to negative F prime gives me a local max. That looks good. Okay? Now let's look at the F and F double prime, the new thing we learned. If this is F double prime, it stays positive to here, which means the F graph should be concave up till there. Then this goes negative, which means this should switch to concave down. That looks good. I think it's the red connection. So I think it's CBA. So I think we got that. So what's happening here? There we go. Lynette, Emily, Matt, Reed, Jordan, Casey, Maddie, Clay, Katie, Joe. Good job. CBA. CBA. Little piece there that kind of threw us off, but it was pretty close. All right. 27. I don't have a picture of 27. And we're about out of time anyway. So I'll leave that for you guys when to try. Of course, the answer's in the back, but that's a good question to do. All right. Homework. Again, it's a little different than what you're going to see on your assignment sheet. So 1.6 is going to be 37 through 45, which is another one of those sections like we had today. They give you an F prime or an F graph, ask you all these questions. We can't get enough practice on those. So that's 1.6. 1.7 is 14 through 22, 25, finish 27, which was like the one we just did, which was 26. 32, 33, 43, and 44. Okay, and then, I'm just kidding. All right.
Oh my gosh.
So that's it. Remember Monday? Remember the assignment the other day? Remember. All right. The easy one? No, you get a short memory. Okay. All right.
Need a reminder.
Remember that one day? All year long. Okay, so now the 1.7 section, some of those problems will be just like F prime, F double prime. You know, so the only new thing we really brought in was that F double prime F connection today about concave.
I have a question real quick. So I got like totally lost, and because I'm lost, I'm falling behind super fast. So when you're talking about increasing, do you just mean when it's above right here? You mean when this slope's increasing?
No. Okay, those are two different things. The first thing you said was when it's increasing, and then you said when the slopes are increasing. Those are two different things. Okay? If a function is increasing, if I say a certain function is increasing, then we just mean it's going up. That just means going up.
If you want you to fill out our classes, we need it yourself.
So it could be anywhere. It could be positive, negative, whatever. It's just going up. If you say slopes are increasing, that's a whole different thing. Slopes increasing would be that. Slopes increase because these are negative, like negative 3, negative 2, negative 1, 0, 1, 2, 3. So you've got negative 3, so negative and getting less negative, that's an increase. And then positive and getting more positive, that's an increase. So slopes increasing is different than, see here you'd be looking at the y values for increase.